Hello, this is Stefan again from schristoph.online. Today we'll talk about my latest blog post, part 2 of the MCP series, where I turn the AWS guidance on tool design into runnable code. Two demos, a token text counter that reproduces the 250 to 500 tokens per tool claim, and a granular versus coarse comparison that cuts model round trips from 3 to 1. Let's dig in. The guide makes a checkable claim. A typical tool definition costs roughly 250 to 500 tokens. So 20 tools cost 5 to 10,000 tokens on every model call, before any user input. That is the cost of carrying tools in context. I didn't want to trust that number, so I built a realistic 20-tool GitHub server and counted the tokens with a standard tokenizer. The surprise! Minimal definitions came in at about 92 tokens each, well below the band. Then I enriched the same tools exactly as the paper recommends: output schemas, prompt style descriptions, concrete examples, and it jumped to 346 tokens each, almost 7,000 for 20, squarely inside the band. So the band is the cost of good definitions. Every token you spend helping the model pick the right tool is sent on every single call. Now, a critical reader will object. You used one tokenizer, so aren't the absolute numbers meaningless? Fair, and the post says so. Treat the absolute count as an order of magnitude. What survives any tokenizer is a relative comparison. Minimal versus enriched is a roughly 3.7 times ratio, because an output schema and examples add proportionally more text in every encoding. The point is that enrichment costs 3 to 4 times, not that a tool is exactly 346 tokens. The central design tension is granularity. A granular design exposes one tool per API call. A coarse design exposes one tool per workflow and hides the orchestration inside it. The paper's rule is concrete. If a common workflow needs 3 or more separate calls, bundle them into one tool. So I built both designs for the same task, filing and triaging a GitHub issue. Here it is in one picture. On the granular side, the model is forced through 3 round trips: create, then label, then assign. On the coarse side, one tool does the same 3 backend calls in a single model call, with the sequence run deterministically inside the tool. Same backend work, 1/3 the model round trips. Running the comparison shows it plainly. The model round trips drop from 3 to 1 for the same backend work. That's lower latency, lower cost, and the part I care about most, no opportunity for the model to drop a step. A granular design lets the model create an issue and forget to assign it. A coarse design cannot forget, because the sequence is code, not a model decision. But here's the honest trade-off you might raise. Coarse tools hide orchestration, where the model can't see or recover from it. True. Bundling makes the sequence deterministic code, which removes the forgot step 3 failure, but also removes the model's ability to adapt mid-workflow. The discriminator is determinism. Bundle when the sequence is fixed, keep it granular, or use an agent as tool pattern when it genuinely needs dynamic decisions. And all of this is runnable. Here's the companion code on GitHub. It uses the official MCP and Strands agents SDKs and makes no network calls. The GitHub examples run against a mock backend. One command runs all 3 demos: the token tags, the granular versus coarse comparison, and the linter you're about to see. The remaining rules are mechanical enough to lint. So I wrote a linter. It checks 4 things from the guidance: 8 parameters or fewer per tool, domain-noun-verb naming, read verbs kept distinct from write verbs, and a server split once it passes 50 tools. Inject a do-everything tool with 9 parameters and a bad name, and the linter flags it. That's the guard worth running in CI. You might ask, what does the 8-parameter rule actually guard against? Tools with many parameters are harder for the model to fill correctly, and they signal an overbundled, ambiguous tool. 8 is the guide's threshold, and the linter encodes it so a 9-parameter tool fails the build. It's a heuristic, not a measured cliff, but the value is forcing a conscious decision instead of silent parameter creep. The naming standard looks cosmetic until you see what it does to a sorted list. Because a noun is the organizational boundary, sorting alphabetically clusters every operation on the same resource. Issue, create, get, list, update, then pull request, and so on. The model scans a list grouped by resource instead of a jumble, and you get name collision protection for free. I claim a legibility mechanism here, not a benchmarked accuracy gain. And the independent backing, Anthropic's engineering guidance on writing effective tools for agents here. It argues from a second source that loading every tool definition up front is wasteful and degrades performance. The same context economics the AWS guide quantifies. Reading it alongside this post reinforces the conclusion. Spend the enrichment tokens, but keeps the tool count low. Tool design decides what your tools are. Part 3 decides where they live. Hosting, from a local studio server through a remote server bounded to a single AWS account to a managed gateway. I deploy a real account-bounded MCP server to AWS, connect a signing client, and tear it down with the actual output. That's where the governance security model starts to bite. Thanks for listening. I hope this was helpful. If so, you can reach out on LinkedIn directly to get in touch with me or head to my blog at schristoph.online. Let's keep in touch. Take care.